Hi everyone. In this video we are going to present in details PSPM IoT project. We will start talking about the architecture of the platform, showing how all the involved actors work within the system and how they communicate. The core of the platform is composed by two catalogs, the Patient Resource Catalog and the Service Catalog. The service catalog is the entry point for all the services and applications that takes part of the platform. It also provides information about the endpoints of all patient resource catalogs and services. The content of the JSON file is exposed on the local network by exploiting REST web services. The URL address of the Service Catalog API is contained in a configuration file, a JSON file used to configure the platform and to allow the proper working of all the microservices. The Patient Resource Catalog is a JSON file used to provide information about all the devices and resources associated to each registered patient. It is also based on REST web services. Now, we will discuss about the microservices concerning the data generation process. The data generator service is an implementation of a sensor data emulator. It retrieves information about patients and sends the data to the message broker, working as an MQTT publisher. The message broker provides an asynchronous communication based on the publish-subscribe approach. In order to do this, the message broker exploits the MQTT protocol. The ThingSpeak adapter is an MQTT subscriber that receives measurements from the data generator. It retrieves information about patients from the patient resource catalog. It routes data and uploads them on ThingSpeak patient's specific channel through REST requests. Now, we are going to describe in details all the microservices that deal with user awareness, post-processing, and control strategies. ThingSpeak is a third-party software and an open data platform for the Internet of Things to store, post-process and visualize data trends. Alarms Handler is a control strategy that manages data retrieved from the ThingSpeak platform and sends an alarm message depending on 3 thresholds provided by the Patient Resource Catalog. These thresholds could be defined with the support of a specific physician or family doctor. The alarm are sent via Telegram bot and Twitter. Twitter is a social network that can show information about the proposed platform. It also integrates the possibility to show alarm messages sent by the Alarms Handler microservice. PSPM Telegram bot is a service to integrate the proposed infrastructure into Telegram platform, which is a cloud-based instant messaging infrastructure. It retrieves measurements from the ThingSpeak platform and allows only authorized user to access them. Statistics Handler is a post-processing strategy that calculates statistics about patients' health status. In order to do that, this service exploits an algorithm based on a series of fuzzy logic rules and sends the results to applications who request them through REST web services. Freeboard is a dashboard used to retrieve data and information of a specific patient. It shows an overall view of the patient's health status exploiting REST web services. All the presented microservices communicate exploiting 2 different protocols, REST and MQTT. Communication with REST protocol is indicated with a white line, while communication via MQTT is indicated with a black line. It is worth noting that all the microservices receive informations on users and resources both directly and indirectly from the two catalogs and the platform core. The entire platform is built using the microservices approach in order to achieve scalability and delocalization of the system. First, we have to run the Service Catalog API, which is mounted on this IP address and this port, as we can see from the screen. Then, we run the Patient Resource Catalog API. After the launch, we can see how, in this particular case, two put requests are sent to the Service Catalog, in order to register the two patients in the Patient Catalog JSON file. Now, we can launch the data generator. It works as an MQTT publisher, generating emulated data for each patient. In this case, it will publish data to the broker each 20 seconds, as we can see from the screen. Then, we can run the ThinkSpeak adapter, which receives emulated measurements from the data generator and publishes received data in real time onto the ThinkSpeak platform. Then, we run the Telegram bot, as you can see in the left screen. We will ask for patients' vitals, showing how only allowed users can access to them, according to the chat ID provided in the Patient Resource Catalog. Now, we run the Statistics Handler API. It will retrieve data from ThinkSpeak platform, according to a defined temporal window, and it will automatically determine patient status, thanks to the use of a series of fuzzy rules. At this point, we can launch simultaneously the Freeborn API for all the patients, 2 in our case. The application will automatically retrieve the patient's status through a GET request we can see from the screen. Now, we set the data generator to send non-physiological values in order to test the alarm handler service. These data will be uploaded on ThinkSpeak platform, as we can see from the screen. For this demonstration, the time window for processing patient data is set to 5 minutes. When an alarm is generated, it is automatically sent to the Twitter channel and to allow Telegram users. PSPM. Health made easier.